Greetings, ladies and gentlemen. We are here today to continue our work with factoring and actually get into solving equations where we're actually trying to find numerical numbers for x. So problem 1 here, as you see it, it is already factored form, so it's pretty much set to solve. And we're looking for values of x that will turn either set of parentheses equal to 0. This is the obviously easy one. The other one, with a little thought, you can come up with your own little shortcut. But normally I will just simply set it equal to 0 so I know I will get the right answer, and then solve this the normal way as a linear equation. So we end up getting 5x equals 2. Final answer would be 2/5. So again, each factor will have an answer. So if we have 3 factors, we'll have 3 answers. For this next one, if you want to try to solve this on your own, you can pause the video and come back and we'll compare steps. So I'll give you a second to do that now. For this problem, it's not in factored form, so we do want to get it into factored form. Suggestion here, since each of the coefficients is even, we'll divide by 2 at the beginning, and that'll leave us with something a bit simpler to work with. Now here's a problem where we have to use our x and our box to come up with the final answer. As usual, the middle term goes below, and recall here we have to multiply the 3 times the 5. The numbers we're looking for would of course be -5 and -3. And these numbers are the ones that get set into the boxes that are empty after we simply copy the first term and the last term in. And now I'll bring in the numbers I discovered from my x method, remembering that each of these ones in red ink here have an x attached. Make that look like an x. Because these represent the 4 parts of FOIL. And now our method here was to factor vertically what does each have in common, and to factor toward the left. So if I look at my right-hand column, it looks like a 3 occurs in each of these terms as I factor vertically. And as I factor vertically this column, each term has a 5x. I will now approach this toward the left, and each of these shares an x. And on the bottom, there's really nothing besides the 1. Looking then for the symbols I will use, those come from these red numbers here. And my factors appear to be 5x minus 3 times x minus 1 equals 0. And then to get the answers, of course, I simply set each set of parentheses equal to 0 and solve for x. So these skills we've learned for factoring actually come back and help us solve equations. Notice this problem has 4 terms of varying degrees. So this is one, as we've seen before, is a classic factor by grouping. So if I focus on this first term here, I can see each term is going to have an x squared, and that'll generate a 3x plus 1. And then I realize that this has to be a perfect match. So I can work backwards and think what'll get me back to a -12x. That is, of course, a -4. So then if I pull together these 2 parts as one factor, x squared minus 4 times 3x minus 1, I'm ready to go. Notice, of course, here that this term can also be factored. This is a plus-minus pattern. So it looks like this particular equation will have a 3-part solution. Again, we're looking for numbers that will force this equal to 0. And this last one will be a positive 1/3. Again, if you're not sure how that happened, there is kind of a shortcut I'm using. But you're always welcome to write this out and then solve it down as you normally would. Our next example, number 4, notice we have the x in only one side of the equation, so it's already pretty good to go. We do have to combine these 2 fractions into one term. Of course, to do that with subtraction, we have to find a common denominator. Very simple to do in this case. We end up with -3/6. And of course, let's simplify that down to -1/2 before we continue and copy the rest of my problem over from the right-hand side. Now I've got a classic case of cross multiplication. We're only allowed to cross multiply. You might remember if there's an equals in between. So I end up with -1x equals 2. Division or multiplication by -1 generates the answer of x equals -2. And that's something we could certainly check by subbing back in this case. I'll leave that up to you. In our last example for today, we proceed to slide 5. And notice here we've got a little more complicated issue going on. But we've done problems like these before, we just haven't solved them for a final value. So, check out what's going on here. We need to generate for ourselves a common denominator. And of course, if we factor the first one, we see that for the other two, x minus 1 here, we got a 4 up top, and for the other term over x plus 1, I don't have to actually multiply each term by the other, but I can get away with something a bit more compact. X plus 1 here, x plus 1 here, and on the other side of things, x minus 1, x minus 1. And now since my denominators are the same, I can only worry about the numerators to get numbers there that will make things equal, because the denominators, it doesn't really matter what they are. They will be the same value. So now everything is over the same denominator. And I need to combine 4 minus. Notice up top here I'm subtracting this whole portion. So let's make it minus. Let's distribute that out right away. 2x plus 2. And then my equal sign. And of course on the other side, let's multiply that out right away with the distributive property. Minus 3. And that's all over the same thing I had. X plus 1 underneath the first. So this part over on the left is where it can be a little bit tricky here. This is 4 take away -2x, and it's also take away that positive 2. So this 4 ends up subtracting 2. So I'm going to get 2, and there's no x term out here in front to subtract my 2x from. It will turn into a minus 2x. All over, of course, the same denominator. And then here I have 3x minus 3. I'll slide this up a little bit, make some more room for us. And now I can just set the numerators equal to one another. And so 2 minus 2x must equal 3x minus 3. I will add 2x to both sides. I will add 3 back to the other side. And that leaves me with 5 equals 5x. So it looks like the only number that should work here is x equals 1. However, if we look back at the beginning, if I have a value of x equals 1 and I start to plug it back in, that's going to generate a denominator of 0. So in this case, I pretty much have to write no solution, because the number I actually found doesn't work in this particular problem because of the denominator. So we've taken a little bit to find the answer, but we find out it's not an answer that we can use here to help answer the question.